Alright, this is chapter 4 and it is about motion in a plane. So you have seen in chapter 3 about the motions of an object in a straight line or a rectilinear motion. So when a body moves along a straight line, let's say along x-axis, then there are only two possible directions for the body in this case. And the directions of body are assigned by either plus or minus. Okay, so when the body move towards the positive sides of the x-axis, the directions of motions is said to be positive, and when the body move towards the negative side of the x-axis, the directions of motion is said to be negative. So only plus and minus are used to signify about the directions of either displacement or velocity or acceleration. Okay, but when the body move in a plane or in a two-dimensional plane, let's say, okay, where we have two coordinate axes, x and y. So when a body moves in this plane, then there are many possible directions of motions of a body. Okay, so in that case, we need to introduce a new term called vector. Okay, so with the help of this vector quantity, we can tell about the directions of motions of a body. All right. So without wasting our time, so straightforward, we will go to vector. So I hope you still remember about vector in class 9. You have learned about the definitions of it. A vector is defined as a quantity which has both magnitude and direction. Okay. Example like displacement, velocity, acceleration, okay, etc. Okay, so these are vector quantities. All right. Now, how do we represent a vector quantity? A vector quantity is represented by a straight line with an arrowhead over it. Okay. Suppose this is a line. Let's say this is AB. Now, as you can see, this is the length of the line. So the length of this line stands for the magnitude. What is the length of the line? Stands here. It stands for the magnitude of the vector. And this arrowhead here, it's very important. Okay, it points in this direction. So this arrowhead, it means it tells you the directions of the quantity. All right. Okay. So this is how we represent a vector, right? By a line and along with an arrow. Okay. Now, because as I said, there are many examples of vectors. So in general, let me represent the vector quantity like velocity. Okay, velocity is a vector. So for velocity, we denote it by the symbol v. If you write only v, it means it's a scalar quantity. But if you write with an arrow on top of v, then this will give you the full meaning of vector. Okay, so v along with arrow on top stands for the vector quantity. So this is my velocity vector. Okay, in general, let's say any quantity, it is represented by a. So a, if a vector quantity, then I should write it up, with an arrow on top of a. So this, right, will give you the full meaning of vector. Okay, and as you know, vector is defined as what? As a quantity which has both magnitude and direction. So if a arrow is a vector, then I can say a arrow is equals to a times A cap, where A here stands for the magnitude, and this A cap, it tells the directions of this vector A. Okay, so this is how we write the vector quantity in terms of scalar and vector. Okay, so please remember this A stands for magnitude and A cap here tells the directions of this vector A. Okay. Okay, next we will look at position vector. Consider a coordinate axis x and y, and this is the origin. Okay, so this xy coordinate axis, it means the object is moving in a plane. Okay, because in a plane we have just two coordinate axes, that is x and y. Just like the plane of this boat, there is only two axes, one is x, another is y. Okay, suppose the object is moving in this plane. Okay, let us consider this object is moving, and let's say at a time t, the object is at this point P. Suppose at a time t, the object is here. Okay, now this line OP, this OP along with arrow, this is known as the position vector of the object with respect to the origin. Alright, so we defined position vector as a vector which gives the positions of an object with reference to the origin, okay, of this coordinate system. Okay, and we represent the positions vector as OP. This OP here stands for the magnitude. Let's say if this is the distance, I mean if we talk about displacement, then this length OP would mean the magnitude of the displacement, and this arrow here, it tells the directions of the displacement of the object. Okay. Okay. Next vector is displacement vector. So we define a displacement vector as a vector which tells how much and in which direction the object has changed its position with respect to the origin. Okay. Again, we consider the motions of an object in a plane, that is in a two coordinate axis, x and y. Now let's say at a time t1, the object is at a point P, and the position vector of this point P with respect to the origin is OP arrow. Okay, suppose after a time t2, the object has shifted its position from P to Q. That means it changed its position. Okay, so when the object is at this point Q, now the positions vector of this point Q with respect to the origin is written as OQ arrow. Alright, so I can write like this. Suppose this OP arrow is written as R1, which is the positions vector of the point P, and R2 is the positions vector of the point Q. Then the displacement vector, now the object is changing its positions from P to Q. So this PQ arrow here, this PQ arrow is known as the displacement vector. Okay, suppose if I write this as delta R, let's say delta R arrow, then my delta R arrow here will represent the displacement vector. Okay, and we shall see later that the displacement vector delta R is equals to R2 arrow minus R1 arrow. That is the final position vector minus the initial position vector. Okay, right? So in the next video, we shall see some more topics about vectors.